Okay. Hello everyone, thank you for coming. Do you want to watch it again?
Yes, please.
Okay, sure. Well, no, what do you? So yeah, that's it, everything of this meetup. Cool. I do have slides. So first of all, really thanks for Jay making this video. Capture all the things he's sitting behind. If you meet him, tell him how awesome he is. Usually I will just do an intro, and today I actually want to talk about what happened in the past year in organizing this meetup. My name is Mila. I work at AWS as an open source program manager, and I'm also organizing this meetup in New York. About a month ago, I realized, last year, July is the first time I organized this meetup in person. And how excited it is that we are making our first year mark. And I started to look into the meetup group, the meetup page. Like a lot of people maybe know about this event from the meetup page. And this is a meetup page group. We have over 3,000 people. And the event initially posted there. And as I dig into the history, I found a lot of things that's super cool and I'd love to share with you today. First of all, do you know this meetup actually started from 2008? It's already 18 years old. So exciting and surprising. And it's alive all the time. Every year there is events, except for 2021 because of COVID, there's only online events. But I would say nothing stops from this group come together to share. Even though during the COVID time, we didn't stop on sharing the knowledge, but we just go online. And as soon as we have the chance, we come in person to continue this group as a community, as a group of people who are passionate about PostgreSQL. Of course, all those events cannot happen without people behind it organizing it. And obviously, organizers' work is behind the scene. There's a lot of coordination with sponsors, with speakers, ordering food, making sure things go smoothly. So I really want to give a shout out to Mason, who helped me in the past year post every event on Meetup. And he's the person who has been picking this Meetup for 17 years. How amazing it is. He's almost the one at the beginning. And also there is a few organizers who carry it over, Jim and Jonathan, who sit in front and who has been together helping us to initiate this Meetup again. And JD. And without speakers, we don't have a meetup. If you have been a speaker or you have been thinking about being a speaker, you know how difficult it is. You need to put real time, effort in organizing your thoughts. And it takes real nerve to stand in front of a group of people to talk about what you know. And maybe also to be challenged. It's a great experience. And I really appreciate everyone who made to the list and all those who didn't make the list, but they also jumped into mini discussions. They were there in giving lightning talks. They didn't make to the list, but they count, and we should remember them too. One person we cannot miss is Bruce. He has given 10 talks, and what's even more amazing is he doesn't live in New York. He actually lives in Philly. And every time for him to share with this group, he traveled from Italy to here. So if you get a chance to meet with Bruce, tell him how amazing he is and thanks him. With his frequency come to this meetup, he definitely is not the best, but a family member. And here comes to where everyone here actually had a share of. In the past year, we organized the 6 meetup. Like I said, Jonathan is the one who did our first talk. And especially I want to thanks to Jonathan and Peter for the second talk. When the speakers couldn't make it, they were just jumping in, prepare the talks, and then carry it over. And you can see the registration start from around 100 to about 190, 180. That's the growth of the community, and that's everyone here keep on showing up, participating. Really thank you for being here, and looking forward for you to take the next step of joining us in more events and talks. Oh, of course, with our sponsors, really appreciate Datadog, AWS, Google for sponsoring us. And if you're considering being a sponsor, talk to me. Here comes to organizers who help us to have this wonderful meetup in the past year. Justin, who is carrying the camera, taking pictures, and Louis and Jay for making this video. And Lindsay, he actually is the one making a lot of short clips, sharing on LinkedIn, spread the word. He's not here today, a little bit sad. And all those collaborators from sponsor side. Well, really, as I reflect what we have done in the past year, my feeling is that none of this comes with one person's effort. Where we are, it takes years of advocate from the developers, advocates, organizers, all those efforts. And so that all of us, as PostgreSQL becomes everywhere and people are interested in learning more about that, I'm sure you also have your PostgreSQL stories, journeys that you can share. So join us to be a speaker, to be an organizer, to marketing what we are doing. And if you are shy, connect to me on LinkedIn or anywhere that we can talk more about how you can participate and share your story somewhere, some way. And PostgreSQL Summit is coming. That's in September. We have a $50 discount for everyone joining the meetup. Don't miss your early bird ticket. The next meetup will be Jonathan, our dear friend, sharing about the PostgreSQL 19 in September at Databricks. More information will come on the meetup page. So, join the group so that you will not miss any information. Thanks for AWS hosting this tonight. And here comes event for Migrating at Scale.
Hello. How's it going?
Great.
Good. Okay. Thank you so much for inviting me here. Honestly, this came out of nowhere. I was joining a Slack community for the first time. I was doing introduction, and one of the random blurbs I gave was, I had to migrate our terrible DB choice Firestore to Postgres and data. And it took me freaking forever and half my last lifespan, I feel. And someone was like, why don't you come and talk about your trauma with us? And I was like, okay. Oh, sorry, this is okay, you guys can hear me, right?
Yeah, okay.
Okay. So I was like, you know what? I think that is a good story to share. So here I am. I'm right now I am at Figma. I'm on one of the Make teams, so part of our AI effort. I'm basically building our Make agent. So honestly, if you want to talk to me today about things that are relevant to me, it's no longer databases, it's AI, as I'm sure it's true for half of you here. So feel free to hit me up after this as well. But But before Figma, so I joined Figma in like February this year, but before Figma, I was at Gather for 4 years. I actually have a coworker, ex-coworker here. Hi, Lawrence. My time at Gather was extremely interesting. I was spread across like both the product and the platform team as a software engineer. And one of the most like ambitious and projects that I took on was trying to migrate us off Firestore. And if you're not familiar with what Gather is, actually, has anyone used Gather before during the pandemic? Oh my God, thank you. Thank you so much. I'm not sure if they still use it today, but it's still around. But Gather during the pandemic, it really freaking blew up. It's a interactive virtual space that simulates real life in-person interactions. So I'm not sure like whether you still remember how 2020 felt. But I'm gonna bring you back for a little bit. Do you remember when we were all stuck in our rooms? You can only be on Zoom. And one of the main things people complained about was Zoom fatigue. And so Gather, when they were like really like a budding startup, they kind of help people relieve that feeling. You like go into an online space, you walk up to someone as an avatar, and suddenly your AV just like connects, and it replaces a lot of that in-person, or it helped to like recreate that in-person feeling that you had while you're online. And so it became this like really fun and novel way to host like happy hours or conferences or like anything you can imagine basically. So this is an office. I'm pretty sure this is the actual office we used in Gather. Like we worked online in Gather, obviously. This was a wedding in Korea.
Wow.
I couldn't fit everything within this slide, but somewhere down below here, actually, it's basically it's crazy. It's like a Zoom screen share or something, where one panel was Gather and another panel was like people in person, kind of like watching the event. So you could join either in Gather or in person in like a I can't even remember the word for it, but when you're like separated from each other. But yeah, so this was a wedding. This was obviously a social. Fun fact, I actually got to know Gather through a company social. So before Gather, I was actually working in an AI startup, and then during a team social, we like were using Gather for the first time. And I thought, holy shit, this is the best thing ever. How do I apply and join this company? And I stalked everyone from that company on LinkedIn, and one of the recruiters was like, okay, do you want a job? So that's how I ended up at Gather. But yeah, this was one of the parties. This was actually PyCon Taiwan 2022. So we hosted a bunch of like tech conferences as well, which was really fun. So yeah, one of the really hard problems we had was how do you fit 3,000 people in a virtual space, and they all need like their AV working really seamlessly, and chat needs to be popping. It was quite a difficult problem, to be honest. Yeah, so I think you probably kind of realize Gather's quite a globally distributed product. It's always online. There's always like a wedding, office, social, whatnot happening at any point in time. And so there's like a very interesting problem that we had for us when we were building very rapidly, which is how do we keep building with no downtime? Because, well, it's kind of a bummer if you have to email like people and be like, sorry, like can't use Gather this weekend because so please postpone your wedding. Like that's not really a thing we were trying to consider. But at the same time, we were on something called Firestore, and I'm not sure whether people are familiar with Firestore, but it's this document DB. You basically throw things in and you hope the same things come out. That's how this part is. I think a little bit unfair. It's actually wonderful for like hobby projects. It's really, really not meant for like a rapidly growing startup. So what we were kind of experiencing with Firestore as we were putting more and more data in, and as you can imagine, with a permanently online space that we really cared about latency, really cared about studying. Like you can imagine, like we care about things like frame rate, right? Like when you're walking around the space, you want to refresh at 16 milliseconds per second. We want to make sure that like everything is live, real time, and so like there's a lot of reads, there's a lot of caching, there's a lot of writes as well. When you move across the space, it's 6 moves per second. Obviously, we don't actually do 6 writes per second to a database per person per space. But you can imagine there's like a lot of reads, a lot of writes. And so we were very, very quickly outgrowing Firestore. And we were noticing some like really, honestly, pretty dumb things because of this architecture choice. One was that it was impossible to query anything. Even though data, like, I would say whatever we represented on the map could just be stored almost as a blob or a document by itself. Everything else is just relational data. You want to know about all the users in this particular space, and like maybe you want to query like, okay, of all the people that are present today, what are their emails? And it turns out to be a really difficult thing to query in Firestore if you didn't plan out your the way you design your collections ahead of time. You couldn't even do really trivial things at that point in time, like how many users do we have on the platform? You couldn't even query that. You had to basically write a script that ran every document in that collection and then total it up. It was actually kind of insane. We were starting to realize that every time, because we had so many online spaces that like really needed to rapidly connect and disconnect, we were seeing flaky connections. And so like Firestore was really not built for this kind of real-time sort of connections that have to be extremely low latency and always online. And so we were noticing that sometimes these connections would just completely flake on us, and we would be like rotating server pods just to like spin up the connection again. The other thing we noticed was like because Firestore didn't enforce a schema at that point in time, we basically threw a lot of garbage in and we prayed that garbage didn't come out. There was a lot of data like massaging, there was a lot of hacks all over the code base, there was a lot of like, oh, this failed, I'm gonna silently throw and hope the user doesn't notice, and obviously they noticed because everything's breaking. So there's a lot of like sevs that are just like the data wasn't what we expected it to be, and we didn't handle it in that really elegant way, or we handled it almost too elegantly and then things were silently failing. There was also a really funny limit. I'm not sure whether y'all are aware, but every document had a maximum size of 1 megabyte. And so when we were throwing our maps in, we had to tell customers, oh, by the way, if you build this beautiful map, you can only put 10,000 objects because otherwise it will blow past the document size limit. And obviously our customers couldn't understand why, right? They're like building this like glorious conference spaces, and at some point they're like, oops, sorry, like you just ran out of space. So yeah, it was just like really painful using Firestore. And so like a couple of us, we are from a startup, we're extremely optimistic. We were like, you know what, we're gonna migrate to Postgres. And we're not only gonna do that, we're gonna do it with no downtime. And also we're gonna do it in 3 months. So this is us with an extremely ambitious, extremely naive sort of perspective on what it takes to migrate any amount of data with no downtime. And I think, I'm not sure how many of you here are familiar with database migrations, but all the times when, and myself included, when I wasn't involved in database migration before, I was just kind of like, oh, why can't you just move the data, like just plug it and like throw it into a new data store and it would just work, right? The thing about migrating data or like migrating services in general that's really tricky is that you're basically changing the contract between services. And so like if you have a service that's permanently online, you have this service that's expecting the contract to be in a certain way, right? And suddenly that contract changes underneath you. And this service just goes like, uh-oh, I have no idea what to do. And so basically, if you want your services to be always online, if you want to be always serving your customers, you have to be very careful with making changes and making them in the backwards compatible way. And obviously, like slowly deprecating like all the clients or over time. And so yeah, you have to basically do a ton of prep work for like backwards compat and also resilience to like rollbacks. And so like I'm gonna now kind of speed run you through what it takes to do a database migration. And it effectively involves like these 4 steps. And I think this is like pretty conventional within the industry. It's like nothing controversial or mind-blowing. So I wish I gave you a magic wand in this talk, but really it does not exist. You do still have to do these 4 steps regardless of where you are. And so this is gonna sound very abstract, so I'm gonna maybe draw a diagram for you here. So this is where it starts, right? You have like your client is talking to your server is like reading and writing to Firestore. Everything is like terrible, you want to move. And so before you even like move any data into Postgres, you're like, okay, what do my tables look like? What data do I actually have right now? And how do I like massage them in a way that fits this new role-based schema? And so there's honestly just like a lot of work here, like reading through like hundreds, probably 200-300 million like documents in Firestore through a script, being like, okay, like I think maps look like this. Is this true? And then 90% of the time it's not true. And then you figure out what to do with the exceptions. And so we kind of like crawled through majority of our data, and we were like, okay, I think this is what a space looks like. This is what a user looks like. This is what a map looks like. And how do we like model this in a relational database? So yeah, there was a lot of data wrangling. And I wish I was still at Gather, because if I were, there's this Slack channel called Clown Town, where we post all of the WTFs we found in the code base and in the database. And I would have shown you so many gems, but alas, if only this talk happened like 6 months ago. But it's fine. You can imagine them. There was a lot of, we are a startup, so let's just like ship this. And or there was a lot of like, we actually tried to follow best practice and migrate some data, but it turned out halfway while we were doing a backfill, it would take like 2 weeks. So we just abandoned it. There's a lot of that too. And so there was quite a lot of like, okay, what do we actually think the data should look like for us here? Okay, and now we're like, okay, I think we have a schema. So let's from our services, obviously I'm like vastly simplifying Gather's architecture here, but you can imagine from our like various services, we are now double writing to both like Firestore and Postgres. So if the client like creates a user, this server knows how to like create a document in Firestore, and it also creates a role in Postgres, and probably does some kind of like transformation or adapting, just to make sure that when like everything is just like centralized and like translated properly, right? So at this point you have like data that's like going into 2 databases. This is like honestly the easiest part, because you're not reading anything yet. If your writes weren't quite correct, it's not a big deal. This is your time to kind of like make sure the schema you've defined before, you're really committing to it and looks good. Then comes the part that kind of surprised me by how difficult this was. This was backfilling Postgres, like with all the history that predated the double write, correct? So like, remember at this point, Gather has been around for like a couple of years. We now have a couple of years of data that we moved from Firestore into Postgres. And I think a naive sort of like perspective here would be, oh, you just write a job and it just like writes the data in. Well, it turns out that it's not easy to like batch query things from Firestore. And so like 1, that was really difficult. And then 2, to do it at a really low latency way, that was also quite difficult. And then even writing to Postgres was quite interesting, because we were obviously defining things like indices or indexes or like foreign keys ahead of time, right? And so we were like, oh, we're really clever. We're gonna like just make sure these data gets written in with the indexes and foreign keys. It turns out that really increases your like write time. And so like, I think there was one particular table that I remember. It was something like, oh, to backfill this, like we need the backfill job to basically run for a month. And we were like, okay, like this was one table. Like we had many tables. So we were like, okay, I think this is not gonna work. So there was a lot of like, writing this like CDC sync script in Go that like our really great managed Postgres provider CockroachDB wrote for us that helped to like move data over at a much like higher speed. There was making sure that when you're writing the data to Postgres, writing it without their indexes and foreign keys to begin with, because it really improves like write throughput, and then you can always add it retroactively after. There's like some often data that you always have to clean up because the indexes and foreign keys are not there to enforce the data schema on write, but it's okay. At least you can move the data over. So yeah, there's just a lot of details here that kind of took me by surprise. Okay, so now you've like backfilled your data. Like Postgres is like full of like your historical data. You're writing live production traffic data into Postgres as well. So this is a great time. You can now kind of like verify whether your data looks correct, because when you're dealing with this much data during a migration, very often you get things wrong. And I got many little details wrong. Like for example, one of the things I forgot to like migrate correctly was checking people's like domains when for example, like when you have a virtual space as an office, you can check, okay, is everyone who's logging into this office from Figma.com, right? And only people who are Figma.com can log into the office. I think that was like one of the things that I didn't like migrate correctly. This is like the perfect stage to like get that kind of checking in place. So double reads is basically a time where you read from both Firestore and Postgres, and then you compare the results. You're like, I expect whatever I read from Firestore to pretty much match what I'm reading from Postgres. And anything that is like not correct, you can kind of like log it to Datadog, increment a metric, whatnot, and you can check like how correct your data is over time. Once it's at like a tolerable stage, this is when you're like, okay, like Postgres is written correctly and also reading it correctly right now. And so once you verify those two things are true, you can cut over your production traffic to only read and write from Postgres. So this again sounds extremely simple, but this is the time where you get paid a hell of a lot. And for some reason, I like to put my vacation time right after I agree the migration is going to be done. And so I would be like, day before vacation, I cut over the traffic and I get paid for a week during vacation. So again, like many lessons learned from this experience. But it turns out that cutting over the traffic isn't the final step. You're kind of now dealing with like real production load that is like, there's no fail safes, right? So you're gonna get paid all the time for like anything that you missed at this point. If you miss an index, your query time is slower than expected, you're gonna see that in your metrics, and so on. So ideally, actually, you should probably just verify your metrics are correct at the double reads time. Don't be like me, I didn't verify all of them, and so I get paid on vacation instead. Obviously, like if things are too bad, you could always like flip a feature flag, hopefully, and then it reads from Firestore again. This is again easier said than done because there are so many different places where things could be read or written, and you could like try to centralize them in some kind of like abstraction. But again, it's like easier said than done. And so now you've migrated. Oh my god! I feel like I deserve a clap here. Thank you. So now I'm gonna go into like everything we got wrong, because I think this is what you're here for, the trauma. The first thing we got wrong at Gather was we thought Firestore was a great storage solution for relational data. We were like, you know what? We're like a fast-growing startup. Like we're just gonna like YOLO some data into what seemed like a reasonable choice at that point in time, and then we didn't. I guess Gather just didn't realize it would become such a hit during the pandemic, right? Gather was just like this little like cutesy thing that four co-founders cobbled together, and I think they really weren't expecting it to explode during the pandemic. And also for like context, Gather kind of like started even before the pandemic. They really just happened to be the right place at the right time. I wish after every like slide like this, I usually have a learning, but here I think the learning is just don't use Firestore, please just use Postgres. I think that's the learning. Yes.
That's the question. Right?
Yes.
The original product was Firebase, then Google bought it, and the name changed. It
Yes.
sounds like it was a decent database, and then it became worse.
So yes, you're right, it's Firebase. I think it's still kind of the same offering. I just don't think it was meant to be used the way we were using it. So like if you had planned cleverly what your because like NoSQL is like a legitimate solution for like many use cases, right? I think if you have like a specific use case where you're like a document DB or NoSQL is like good for your use case, I think that's like very reasonable. And to like Firebase or Firestore's like credit, their like read throughput is actually really amazing. This was something we kind of realized was more of a problem we had to struggle with it with Postgres. But there's like really specific use cases for these kind of products, and I think we were just using it wrong. We were trying to like store very relational data, and so it's really hard to join things. Well, it's just not possible to join things. You have to basically pull all your data into the server and join a server within the server, or even was within the client. You like what was another thing I wanted to say? Yeah, so I guess like I think my learning it was just like use the right storage for the right things. I think the next thing that we were really naive about, like I said, was we thought we could migrate Postgres with no downtime within 3 months. We did migrate to Postgres with no downtime. It did not take 3 months. It took us 18 months. Yeah. On and off. It was one of those projects, as you can imagine, within a startup was like, okay, is this really high priority? Okay, we really accelerate dev velocity, and I think it is true. And so it was like picked up on and off by a group of 2 to 3 engineers. Yeah, this was a classic, like, we probably should have realized it's much more difficult than we thought. I think in retrospect, my take down is we should have just, like, tolerated some downtime. I think it was fine, it would have been fine if we just said, like screw it, Gather's gonna be down for a weekend. And, like, we just, like, force refresh all clients. And, like, it would be really, really painful, but we potentially could have gotten it done way faster. I think the fact that we like forced ourselves to do it with no downtime was a quite limiting constraint that potentially as a startup we couldn't afford, to be honest. So yeah, it was a lot of like hindsight 2020 sort of situation. But that's fine. Many things I've learned from that experience. The next lesson I learned was that I just realized this is like quite unclear, but this was the gist here is like we thought, once we're on Postgres, data migrations would be so intuitive, it's gonna be so easy because you have schemas and you have data integrity and so on. So we thought Postgres is just gonna be this magic wand, right? Well, it turns out that backwards compatibility is still really, really hard. It doesn't matter whether it's backed by what DB solution you have. As long as you have multiple services that have a contract with one another, and these services are out of sync, like you have a client that doesn't refresh, you have a service that rotates more slowly than your DB migrations finish, you have an ORM that's like out of step, like it's going to cause problems if you ship anything that is like non-backwards compatible. So to give a very tangible, common sort of mistake that people will make at Gather, they would be like, okay, I'm gonna like drop this like let's say I'm gonna drop a column in the table, right? And they're like, okay, I need to remember that like on my server to not expect this column anymore. So let me first make my server side changes and like, okay, like there's no column. Okay, wait, but like actually I should first make sure the client doesn't expect this data like type anymore. So I'm gonna like remove this data type from the client, wait for 7 days so that the clients get time to refresh and like get up to date, and then do my server changes, and then I drop my column in Postgres, and then it's like a sad happens. And why? It's because, well, I did all this work, but I forgot to like update Prisma. So Prisma was the ORM we were using. We forgot to update Prisma to ignore the column type. And so Prisma does this really weird thing where instead of saying select star from users, it would say select name, comma, email from users. And if you didn't specify ignore on the email column, which is the column you're dropping, it will still try to select that column. And yeah, even if you do a deletion of that column from Prisma, it will still like, for a brief moment in time, before all your server pods like rotate and the Prisma clients are like refreshed, they will still expect the column and everything will blow up. And so yeah, there's like a lot of really like difficult backwards compat things that we have to teach people. Or like we had to create systems so that people didn't have to care about it. But yeah, I guess backwards compat is hard regardless of where you are. The last lesson we learned was we thought that managing a distributed database would be really easy. Turns out that so the database provider we picked was initially CongruentDB because we were like, okay, wow, sharding, they got it. Oh wow, like they've like got all these like amazing like distributed stuff that will make it really easy to serve traffic wherever users are located. Just like lots of great things, right? And we were like, oh, we solved geolocating the databases, but we haven't solved geolocating our servers yet. So then you have like databases that are located in Singapore talking to servers in New York, and it's just like it didn't solve any latency time for users. And so we were like, okay, we might have been a little bit premature trying to pick a distributed database. We also kind of realized that sharding is also not that like easy as people who are new to sharding. We had a lot of DB hotspots because we would do things like store permission checks on a relatively small table. And this entire table was served on one particular CRDB node. And so all production traffic is hitting just one node out of 5. And then we were wondering why our read times were really slow. And so yeah, there were also like DB hotspots that we had to kind of navigate. That honestly was just never a problem before because we just didn't know better. And then lastly was just a lot of quirks just working at CRDB. I'm not here to like recommend you like DB provider and so on, but I think being able to like map out exactly what you need ahead of time and testing these features rigorously on these providers would be a really good and wise decision. So like one example is we were using Firestore's snapshot listeners. So these are basically just like every time like a document change, we get an event, and our services can go like, oh, okay, like your name has changed and I've subscribed to this particular user in this space, so I can update their name in space, right? So it's like a really nice like real-time feature. CRDB had something similar that was quite new at that time called change feeds. We had so much instability problems. We would have like, I remember there was one time, I think we were adding a non-nullable column in a really large table and we were backfilling it. Everything was great. And then suddenly all our I think our database metrics just tanked. And then it turns out that you can't backfill a table too quickly if that table has a change feed. Because it takes a little bit of time for the change feed to catch up. And so like, yeah, this was like just like things we only learned after already being on CRDB and already serving production traffic, and it was like kind of gnarly to walk through. And I also recall like we had like really difficult and annoying local development quirks because you could be on an enterprise feature, but that feature is not available for local development for some reason. And I remember being on a call with CRDB like support person being like, how do you guys do development if you can't access this locally? But yeah, there's just like a lot of really weird quirks. But yeah, I guess that kind of like brings me to wrap up my talk. This was all the lessons I learned trying to move us from Firestore to Postgres. My main advice, as I've said multiple times in this talk, is just pick the right thing to start with, and you can save yourself a lot of trouble. I think one thing I always wish in retrospect was just we pick some Postgres provider to begin with, and I think moving would have been a lot more trivial. But alas, Yeah, so questions. Okay, I'm gonna do a quick drink of water if that's okay. Hello, yes. What's your name?
John.
John, hi John.
Hello. So you mentioned snapshot listeners, and I guess like one of the key things with Firestore is the ability for the client directly to read the database. Were you guys together allowing clients directly to read the database? Were you like isolating everything to the server? So that's my first question. And then secondly, if you weren't allowing the database to be directly read by the client, how was the real-time features just implemented, like directly with the API to the server instead, and you guys weren't leveraging that from Firestore at all?
Yeah, so first question, everything was run on the server, the client doesn't read the database. Second question, how do we like build the real-time stuff? It's actually really similar. It's actually really similar to Figma. Figma is also a very real-time app. You basically deploy stateful services where your clients can be routed to the. So let's say all of us are in a virtual space together. We get routed to the same game server that's hopefully geolocated quite close to the majority of us. We connect via WebSockets and then we listen to events. So this is what kept like latency extremely low. Also, I think one of the best practices around like real-time communication between servers and clients.
Okay.
Yeah. Hello. What's your name?
My name's David.
Hi, David.
Hi, I'm not an engineer, but or database person, but I'm more of a project manager. So I was curious, were you the project manager on this, or were you the engineer, or how many people were in it, and why is it a three? So when you're doing a BRD or a business requirement document, you're also doing some estimation of how long it takes, how much money it takes. 3 to 18 months is huge. So I'm just wondering, what were your assumptions and why did it go from this to this?
Yeah, I was one of the engineers on this project. I ended up being the one migrating some of our largest collections over to over to Postgres. I would say in terms of estimates, I think it was just like naivety. Like we didn't really know what it would take in terms of migrating real life data that is hitting our services very rapidly to another solution with no downtime. I think we should have probably relaxed some of the no downtime constraints. We were extremely like mindful of how we did it. Remember, like let's say for example, we have clients that are like we would deploy changes on our web clients and wait 7 days so that clients have time to refresh over time, right? Like so. Every step in the deployment, in the migration process per collection/table can take 6 weeks, right? Because you're like just waiting for clients to refresh, waiting for things to just, you're also like making sure you don't deploy every change back to back to prod, because if there is just a broken like release for some reason and you need to do a rollback, you can get into a really screwed up state because you roll back to some weird intermediate state. And so there's just all these considerations, which then like lengthened even a single like collection migration, if that makes sense. I think we just didn't anticipate it. Yeah, and no, we didn't have a project management. Maybe that's fine.
Thank you.
Yeah. Maybe I'll take over this side a little bit. Yes.
Did you consider like alternative flexible ways maybe with the integration and also serverless? I know you mentioned but the serverless Postgres, so you could export the JSON documents.
Yeah, I think we like explored a bunch of like DB providers. I remember like Aurora, Superbase was one of them. SerDB, like self-host. But I think we like basically did a POC with all of them, and then we like measured like read times, write times, and so on. And so we had some sense of like what the performance was for like every provider, plus what kind of support we were expecting, plus like what kind of feature parity we were getting. And I think we just landed on SerDB for like a variety of reasons. And some reason turned out we didn't need because we weren't ready there yet architecturally, but that's okay. Now we learn. That's how we learn. Yeah. Yes.
Hi, Armand. So you talked about different providers for Postgres, but I want to know what was your decision on using Postgres as a relational database instead of other different relational databases?
This is where I'm like, I wish I could like illuminate more here, but I wasn't the one who was involved in the initial POC. I I think Postgres was just a very reasonable like initial choice. At that point in time, I think even now it's just like known as to be generally a superior like relational database choice compared to MySQL and some of the other solutions. I don't think we like overthought this. I think we just took like the whole like choose boring technology like route. Yeah. Yes.
Thank you. This is great, and as you promised, I feel some shared trauma. So.
Thank you. So what's your name?
My name's Josh.
Josh. Hi, Josh.
One of the things that's, having been through this before, one of the things that I'm curious about is during your period of double writes, what was your general strategy for those double writes? Like, how much did it matter that you had exact parity?
Oh, you mean exact parity between Firestore and Postgres?
With the writes, yeah.
Yeah. I think it's like pretty important, but then like once you kind of locked a schema in place, I mean this schema is translated as maybe a TypeScript type that's propagated throughout the rest of your services. So like you would expect the user to be a certain shape, and that's the shape that's being written into Firestore or Postgres. Actually, what you said brought up a really interesting point around every time we were migrating a table, we will tell people, hey, you can't really do you can't change the type right now. Like, if you change the type, I have to backfill everything again, I have to double write everything again. Like, please don't do that. So you basically like every time we like decide to move a particular collection into Postgres as a table, we will almost like freeze that type and tell people like, okay, this is the type we're committed to at least for the next 6 weeks, and we're gonna move this type kind of as is like into Postgres. So yeah, it was actually quite important that it stayed static and was consistent. Yeah. Hi.
Hi, Devin. My name's Devin. Sorry. My startup, we built a product that does all this as like a gateway that intercepts TCP traffic, yada yada yada. So like I've seen a lot of this, especially going from like NoSQL to SQL databases. But one of the biggest challenges that we have is coming to your point, all the pre-mapping and the schemas. Like because we intercept all the TCP traffic, like we block DDLs. But it sounds like you didn't have a clear schema at the start, so that becomes really hard where you're doing this all on the fly. And then it sounds like because of how the data comes from Firestore, like we do Mongo, we went through Firestore. You had to probably define all this logic in code. So I was curious, what that process looked like, where you just have these things that you're not expecting to pop up, and then you have to take pretty much all this handheld stuff that's in code and then unroll it. Because for us, like we just provide the same IO, right? Like if you're going from like let's say Mongo to Postgres, like the IO has to be the same. But when you're doing all this hand rolled stuff in your code, then it actually won't be the same, and then you're doing the matching like in that kind of, I don't know, mess.
Yeah, totally. Yeah, it was just through a lot of blood, sweat, and tears, honestly. I think we query a ton of data to kind of get a sample of what's actually in our databases when we were kind of designing the schema and then doing the mapping. Some things we almost just decided wasn't worth it. You can imagine like, because we realized there were no joins in Firestore over time, people obviously got kind of like, they had workarounds, right? Which is like storing nested data structures in a field. And so you had to unroll those fields if they were really important and you cared about data integrity and you wanted to add foreign keys and so on. For things that like wasn't that critical to the business, we were like, I think it's fine if we just like kept it as a JSON column and called it a day, and we just didn't look at what was inside. But anything that was actually critical to the business, like a user email, we made sure like that was like stored correctly, that was joined correctly, that was actually unique, and so on. So yeah, there's just a lot of like sampling, designing the schema, then trying to backfill, realizing you got it wrong, and then redoing the whole thing for like weeks. Yeah. Hello.
I have two questions about Prisma, right? So Cockroach DB is not a perfect subset of Postgres. Did you run into any problem that Prisma was expecting a behavior and Cockroach DB did not? pattern behavior?
So when you pick, I'm not currently using Prisma, it might be a little bit outdated, but I believe when you use Prisma, you specify which kind of provider you're using, so you can specify CRDB and it will expose the right features. But you're absolutely right. There were CRDB is a subset of Postgres and a subset to it depends on how you look at the feature set, but there were definitely moments where we were like, oh, we wish we had this feature, but the ORM couldn't, it just wasn't available because there was some kind of, what's the word for it? ORM impedance thing mismatched. Yeah.
Okay, just a follow up then, if you had the geo-replicated shards, did you end up deploying Prisma across different regions also, or?
So the way we were using Prisma, Prisma is basically like a very lightweight, I say they call it client, but basically just something that your backend services kind of spin up and that's it. Instead of reading and writing to the databases directly, it uses the client to kind of understand the shape of the database, the data in the database. Basically wherever every pod, every server pod we were deploying, they had their own internal Prisma client. If that makes sense. Yeah. Hello, yes.
Yeah, thanks. I have a question. So you said you used Prisma and you used the sharding. I guess that's because the writes, there's a lot of writes. Is that the main reason you use that, or?
Yeah. Why do we use sharding? I guess is the question.
Did you use Cockroach because of the sharding?
Yeah, I think one of the reasons we picked CRDB was it promised that it can handle really high throughput. I think that is kind of true. It was pretty easy to I remember it was pretty easy to horizontally scale nodes across your CRDB cluster. You just need to make sure that you've sharded your data correctly. So just making sure that your traffic's actually divided across all the nodes that you have available. Otherwise, you have DB hotspots and then it defeats the whole point of having a distributed database. All your traffic is going to one node. Yeah. Yes.
Abraham. One of the, unspoken things here is that one of the actions is to build some technology on top of what you already have, like an extra index using the strings or whatever, to solve some of this. You have to do this again. I know one of the actions was relax some of the online constraints, but would you consider either temporarily or just permanently building on top of the existing system to make either the migration easier or the system just work better?
Yeah, I think that's a constant tension, which is why this project also took 18 months. I think there was a mix of do we really have to migrate? Maybe we can just stay on this as is. I think the reason why we decided to bite the bullet in the end was, as you can imagine, as the pandemic was winding down, we've kind of realized our business was kind of cooling because again, I think Gather solved a very particular problem during the pandemic. This kind of meant that we went into a slightly existential moment where we were okay, maybe our business is not going to grow as quickly as before. We better figure our shit out basically as a startup. And so we were trying to ship a lot of new features very quickly. And I think the problem with shipping really quickly is you either put in a bunch of hacks because you assume that the data you're getting is garbage, or you can lean on certain data integrity, right? And you don't have to worry about these hacks. And so we decided that the latter was the wiser choice. And so we kind of committed to the migration eventually. And I think it makes sense because I'm not sure whether you've seen Gather more recently, but it's really pivoted towards this remote work offering where you can have a virtual office online with your remote coworkers. And honestly, a lot of the features that we built, it was accelerated because now we had a database where we knew that we put things in, we get the same thing out. Yeah. Hi, yes.
You mentioned some backfilling took 2 weeks and then you canceled it. Did you find the root cause of what went wrong with it?
Oh, I think someone just gave up. There there's a lot of very well meaning like, okay, we should do this correctly. So if I'm changing the data type within, if I'm changing data type, our data is in Firestore, that's actually like backfill the data correctly. Like you can imagine you remove a field or you like add a field or whatnot, right? And some well-meaning engineer would try to actually do the migration of some script that's running on their laptop for like 2 weeks. And then halfway through, they're like, I actually do have other priorities. And so they gave up. So there's a lot of that as well. And as you can imagine, like all these migrations are happening ad hoc as well. There's no concept of like a migration history, right, with Firestore. And so like, it's not like I could even track all the migrations that happened in the lifetime that we were using this. It was just, we discovered it. We just discovered the skeletons in the closet as we were trying to migrate the data. Yeah. Hi, yes.
David Wong again. I'm not sure if this is winding down, but whenever I go through any trauma, I look back and say how I've grown through this. So were any personal takeaways or any growth lessons you learned?
Firstly, I wouldn't use Firestore. I would just pick Postgres. I think it's a very reasonable option for many, many, many use cases. I think the second thing is, every time I say this in front of my Gather Expo workers, they would kind of laugh because they were like, we will like historically be like, oh, what's the worst project I ever worked on at Gather? And everyone would be like, if they've touched a DB migration at some point, they would be like, oh my gosh, the DB migration is a nightmare. And then I would be like, no, I think the DB migration was the best project I did at Gather. It's more because I think I really gained a rigor as an engineer. I think before that, so my history as a software engineer was I was primarily in startups, and I would have I used to have a much more like just bash things together and like see what happens mentality. So really I was part of the problem as you can see. But I think having been the one to then go clean up all the mess, and to read everyone's code and like find all the skeletons in the closet and like try to wrangle data, I really learned like, okay, what aspect of engineering is a measure twice, cut once kind of deal, and what is like, okay, you can like move fast, you can afford to take on this tech debt. So now like I work at Figma, like obviously we work at even greater scale, right? And the only thing I would like hard veto anyone is when they're making a terrible schema choice. Because I'm like, dude, like really, you don't want to like migrate the data after the fact. It's just not worth it. Like, just like spend an extra 2 days thinking about it. Like, no deadline that urgent that you have to like ship a broken schema. So yeah, I think that's like why I really learned as an engineer, that kind of rigor and like understanding what needs to be built on solid foundations versus what can be like, oh well, we can afford to fix it later, it's not a big deal. Yeah. Cool. Thank you so much for coming. Again, you can reach me on LinkedIn. I just want to also say, Figma's hiring. Our AI teams are expanding very rapidly. If you want to chat on Figma, I'm here, obviously. We are doing some freaking cool stuff. I'm not sure whether you've seen Config from 2 weeks ago, but we're doing a lot of cool stuff with code on the canvas. Yes?
Can you bring someone from Figma to talk about Postgres?
Oh, yeah! I probably could. I'm not sure whether you've seen the blog post. Figma has this blog post about something along the lines of like databases, like their sharding journey, and how they were 6 months away of running out of space. This was when again they were growing extremely quickly. Coming promises, but for the idea to the person who like ran the project.
I think it was called sharding the elephant or something like that.
Something like that. Yeah. How we like live to tell the scale or something like that. Like yeah. I can talk to the engineer who led that. Yeah. Thank you so much for listening. I panicked, prepared this talk literally today morning, even though I know Mila gave me 7 months notice. Yeah.
That's great. It's great, right?
Yeah.
Yeah, very thank you.
Thank you so much.
Yeah, we booked this place till 8 o'clock, so feel free to stay a bit, mingle, chat, to connect with each other, and then we have, like I said, we have our next meetup at Databricks, Jonathan